Hi, these are the notes for H6-6, more properties of logarithms. So in this section here, we're going to talk about a couple new properties here. We're going to talk about the product and quotient properties of logs. We're also going to rewrite logs with different bases. Let's jump right on in. First thing to discuss is we have our two exponent rules from the past. We know that when we multiply two numbers that have the same base, we can add their exponents together. So x to the power of a times x to the power of b is equal to x to the power of a plus b. And when we divide two numbers with the same base, we would subtract their exponents. Okay, our product property of logarithms and our quotient property of logarithms kind of follow these same exponent rules. If we end up adding two logs with the same base, okay, we can take it here and combine it together and write it as one log with the product of their values. Same thing with the quotient property here. If we are subtracting two logs here that have the same base, we can rewrite that as one log with the quotient of their two values there. So multiplication and addition kind of went together, and our division and subtraction go together. We'll look at how these work here in the next slides. So our product property, if we are looking to rewrite these or simplify them as one logarithm, for letter A we have log base 10 of 5 plus log base 10 of 3. We can rewrite this as log base 10 of 5 times 3, or if we simplify it all the way down, this is equal to log base 10 of 15. And that would be our simplified answer there. The second one, this is log base 10. Okay, remember when we don't write the base in there, it's like it's a 10. Okay, but you can just pronounce it as log of 2x. So when we take the log of 2x plus the log of 5x squared, this is the same thing as log of 2x times 5x squared, which should give us 10x to the third power. Remember, if you have any questions about anything at all as you're going through this, just mark it in your notes there, and then let me know and we'll talk about it in class. Let's look at C. Log base 5 of 10 plus log base 5 of 4, that's an easy one. 10 times 4 is going to give us 40, so we have log base 5 of 40. And the last one here, log base 3 of 3x plus log base 3 of x minus 1 should give us log base 3 of, now we would have 3x times the quantity of x minus 1. Remember, you're taking the log of all of that, or it's safe, to say you can go ahead and distribute it if you want to. Log base 3 of 3x squared minus 3x. So those are our answers there. All right, moving on. Let's look at a couple examples of the quotient property. So A, we have log base 2 of x minus log base 2 of y. If we want to use the quotient property, we can rewrite this as log base 2 of x divided by y. So order does matter here. The first value you have is x, the second value is y, so it would be x divided by y. Letter B, we've got log of 5 minus log of 2. This would be log of 5 over 2, or 2.5. Letter C, we have log base 5 of 6 over 3, which simplifies to log base 5 of 2. Last one, log of 17x to the third minus log of 9x. This would simplify to be log we'd have 17x to the third over 9x, which would simplify down to log of 17x squared over 9. Any questions on these ones? Mark it, see me in class, we can discuss it there. Let's move on to the next part. Letter E. It says to solve some equations, we need to have just a single logarithm or a single logarithmic expression on a side of the equation. It says apply the product property or quotient property to rewrite the left side of each equation as a single logarithm, then solve for x. Okay, these are some of the equations here that when you're solving them and have logs on both sides, we want to make sure that if we have multiple logs on one side to start out, we need to get that down to 1. So this is where that product property comes into play. Log of 5 plus log of 6 is going to be the same thing as log of 30. And since that equals log of x, we can see here that for this to be equal to each other, the x value would have to equal 30. Example 2, same thing. Let's use the product property to combine our two logs on the left side. We've got log base 6 of 5 times 2, which is 10. And since that equals log base 6 of x, you get 10 is equal to x. Number 3, log base 2 of 30 minus log base 2 of 3 equals log base 2 of x. Be careful on this one because we have a minus sign here. That means we're going to use the quotient property. So we'd have log base 2 of 30 divided by 3, which is 10. And that equals log base 2 of x. That leads us to have that 10 equals x. The last one here, you can go ahead and work through it. You should get that 3 equals x. All right, moving to the next part here. Letter F. Apply the power property of logs to help simplify or write as a single log. Talked about the power property yesterday. When we look at A, you will see that it's 2 times log base 4 of x. Yesterday we were solving equations and we were applying the power property by bringing the exponent down. Now we're going to take it and we're going to put it back up. We can rewrite this one as log base 4 of x to the second power. That is the application of the power property. Letter B, we can use the power property to start out by getting rid of the values that are out in front, those coefficients. Those are going to each become the exponents on our values. Our first part would be log of u to the 20th power plus log of v to the 5th power. When we want to rewrite this as a single log, because we are adding in the middle, that means we're going to be multiplying the values. We'll have log, and then we'll have of u to the 20th, v to the 5th power. Last, we've got C. Let's take our coefficient, the 1/2, and let's put it back up here as the exponent. We now have log of 16 to the 1/2 power. 1/2 power is like the square root. That would lead us to have log of square root of 16 would be 4, and that would be our answer. Moving on to G. Use the properties of logs to write each expression as a single logarithm if possible. This might be a good time to pause the video, try to work some of these out here, and then play it to see if you get them right or wrong. Letter A, I've got log base 3 of k plus x times log base 3 of m. We'll leave our first expression alone for a moment, and let's just get rid of that x that's in front. We'll move that back up as the power, so we have log base 3 of m to the power of x. And since we're adding those, we're going to multiply their values together, so log base 3 of k times m to the power of x. Letter B, we've got 4 expressions with logs here. Let's just take our time, go left to right, order of operations. So log of 4 minus log of 3 would simplify to log of 4 over 3. And the second one here, this should be a pi symbol, it was left out. But we have plus log of pi plus, and let's go ahead here and move the 3, the coefficient, back up as the exponent. So plus log of r to the 3rd power. Now this is all multiplication, so you could end up with log of 4/3 times pi times r to the 3rd power. And that would be one form of the answer. Others may get the form log of 4 pi r to the 3rd over 3. Both of those are equivalent there. They would both work just fine. C is one that's a little bit tricky here. You see you have log base 10 of 6 plus 23. Now 23 doesn't have a log on it here, but you can think about this as being, and I'm going to write the little 10 here just for a moment so that I can illustrate something here. Log base 10 of 6 plus, well, 23 is the same thing as 23 times 1. And we can rewrite 1 pretty easily as a log base 10. So this would be like saying plus 23 times log base 10 of 10. Remember, log base 10 of 10 is going to always equal 1. Now, because 23 is the coefficient here, we could treat it like it's the exponent and move it up, and then we have 2 expressions with the same log base. So we have log base 10 of 6 plus log base 10 of 10 to the 23rd power. And this will allow us to use the product property. We'll end up with log base 10 of 6 times 10 to the 23rd power. Now we've written it as one log. And remember, it's totally fine to not have the base written in there when it's base 10. I just wanted to write it for those of you who are still new with this. Okay, last one for this section here, letter D, we have 1/2 times log base 5 of x. We rewrite that as log base 5 of x to the 1/2, or some students I know would rather just go ahead and change it to the square root of x. I'm fine with that. Plus, we have log base 5, and we'll take our 2 and we'll move it up here. So we're going to say x plus 1 squared. And then let's put it together as one log. So log base 5 of the square root of x times the quantity of x plus 1 squared. And then I'll put parentheses around all of it because it's all part of the same log. All right, we're moving on here. This is the last part of the notes. Hopefully you're still with me. Remember, you can pause it, rewind, fast forward, do what you need to do. This one says, recalling the definition of a logarithm, you have log base m of a equals n, means that m to the power of n equals a. Just remember, this is our base. That's why we read it as log base m of a equals n. That helps us to remember that's our base. And when you're in log form, that always equals our exponent. So some people like to go around the world. M to the power of n equals a, which is what you see on this side here. All we're going to do with this is we're going to try to rewrite it so that we don't have a log with base 3. We want to rewrite this as log with a base of 10. So here's how we do it. Let's recopy log base 3 of 20. And let's just set it equal to x for the moment here so we can kind of look at what its value is. Let's convert it to its exponential form. So 3 to the power of x equals 20. So we have 3 to the power of x equals 20. And now we can use the power property of logs to help us change the base. So first thing we'll do, let's go ahead and take the log of each side. So we have log of 3x. Remember, when I write just log, that means it's log base 10. And that's going to equal log base 10 of 20. And now we'll move that x out in front as the coefficient. So we're going to say here that we've got x times log, I'm going to write just log this time now, of 3 equals log of 20. And then to get rid of the log of 3 on the left, we're going to divide each side by log of 3, and we should get that x equals the log of 20 over the log of 3. Now each of these expressions here has a log base of 10, and that's exactly what the problem is asking us to do. So it is written as 2 logs, but it is still an expression that is log base 10. If you want to pause the video and try the second one and then check your answer, that'd be great. I'm going to go ahead and do it now though. We'll set log base 2 of 15 equal to x. Now this one we want to rewrite it as log base 5. So we're going to take it and use the exponential form. So 2 to the power of x equals 15. We'll take the log of each side. And we want this log, when we do it, to be log base 5. So I'm going to do log base 5 of 2 to the power of x equals log base 5 of 15. We'll use that power property. So we have x times log base 5 of 2 equals log base 5 of 15. Last step would be to divide each side so that we can get our x by itself. We have x equals log base 5 of 15 divided by log base 5 of 2. And now we have an expression here that is in log base 5. That's what we refer to as changing the base. If you have questions about any of these notes, please make sure that you see me in class, email me, do what you got to do. And that's it. Thanks for watching.